Welcome to Cybersecurity Under Pressure. Real attacks, real lessons. Every breach starts with something small. A trusted login, a missed alert, a system no one thought could matter. Here, we follow the incident. How it began, how it moved, what broke under pressure, and what security engineering and business teams should learn before the next one. Because the next attack will not wait for a perfect plan. Now, let's follow the evidence.
Welcome to Cybersecurity Under Pressure. Real attacks, real lessons.
Glad to be here, as always.
So, imagine for a second that you are the chief information security officer of a massive manufacturing empire.
Oh, wow. Okay, setting a stressful scene right off the bat.
Right, because you've spent hundreds of millions of dollars building this digital fortress around your corporate network.
Yeah, you've got the biometric locks on the server rooms, the 24/7 security operation centers.
Exactly. The military-grade encryption on your primary databases. I mean, you feel pretty good about your posture.
You'd think so, yeah.
But then, as we look at wrapping up the week this Friday, a terrifying reality just kind of sets in.
Right, the Friday afternoon nightmare scenario.
Always on a Friday, an extortionist basically walks right away with the highly classified engineering blueprints to your newest multi-billion-dollar product.
And they didn't burn a zero-day exploit to break through your front door, did they?
No, not at all. They didn't scale the walls of your digital fortress.
Right.
They simply bought a $5 stolen password belonging to a small parts supplier located 3 countries away.
Wow.
And they just walked right in through a side window that you left wide open, basically for the sake of convenience.
I mean, that is the exact nightmare keeping executives awake right now.
Yeah.
We spend so much time, obsessing over the hardened perimeter of the enterprise.
Sure.
But the reality of modern manufacturing is that your perimeter doesn't actually end at your corporate firewall anymore.
Not even close.
It extends outward, branching like this massive digital root system all the way down to a Tier 4 supplier.
Right, like a 5-person machine shop sitting in a rural industrial park.
Exactly. Operating on an entirely different continent, relying on IT infrastructure that might just be a dusty server sitting next to a break room microwave.
And that vulnerability is precisely why we really need to unpack the Stadler Rail breach today.
Yeah, it's a perfect case study for this.
It really is. For those of you who might only know the headlines, Stadler is a massive, highly respected Swiss manufacturer of railway rolling stock.
They build the actual trains that power national transit grids.
Right, and we have been poring over the technical analysis from the CERT-CH advisory.
That's the Swiss government's computer emergency response team. Right?
Exactly, yeah. Along with the deeply detailed reporting from the Register.
Great reporting there.
Really good.
Yeah.
And the facts of this specific case are incredibly revealing about a systemic gap in our industry.
Revealing and, frankly, a massive wake-up call.
Yeah.
The threat actor here is an extortion group known as Everest.
Right.
And they sent Stadler a demand for 10 million Swiss francs.
10 million, that is not a small number.
No, it's huge. But the method they used is really what we need to focus on here.
Because they did not achieve this leverage by deploying a destructive ransomware payload.
Exactly. There was no malware encrypting the operational technology on the factory floor.
Right. They didn't shut down the assembly lines or lock the robotic welders?
No. This was purely 100% a credential-enabled data theft.
Exactly. The attackers just gained entry through a shared supplier collaboration platform.
They quietly exfiltrated highly sensitive engineering data.
And then they held that data over Stadler's head, threatening to publish it to the world if that 10 million franc ransom wasn't met.
Which is terrifying. But Stadler, to their immense credit, famously refused to pay the extortionists.
Which is a monumental business decision in its own right, honestly.
Refusing a 10 million Swiss franc demand when your intellectual property is hanging in the balance, that takes serious corporate nerve.
Absolutely. But getting back to the mechanism, you're completely right to highlight that this wasn't about breaking machinery.
Right. The core business challenge here is really about supplier dependencies.
And the vast, often invisible web of trust we extend to external partners.
Yeah. This incident is not just an isolated bad day for one Swiss train maker.
No, it completely exposes a systemic structural gap.
A gap that currently affects literally any manufacturer, relying on external collaboration platforms to design and build complex, multi-layered products.
It scales up terrifyingly fast when you realize how many partners are actually involved in these projects.
Oh, absolutely.
Mhm.
When you're building a high-speed train or a next-generation commercial aircraft or an electric vehicle, you aren't doing it in a vacuum.
Right. You have hundreds, sometimes thousands of external partners.
You have prime contractors, subcontractors, specialized component designers.
And all of them need access to your central nervous system.
They need your engineering blueprints, your heavy CAD files, your aerodynamic models.
And the software code for various electronic control units, or ECUs.
Exactly. So this sets up the absolute core dilemma that every security leader in the manufacturing sector is facing today.
Right, and it really comes down to this. How should manufacturers secure and govern supplier access platforms to prevent credential-based data theft and extortion without disrupting collaboration?
I mean, that is the central tension of the modern supply chain.
Yeah, it's a constant tug-of-war between security and operational velocity.
Because if you lock down that collaboration platform too tightly, if you build the walls too high, your own engineers cannot share the necessary schematic updates with the external brake manufacturer in time for a critical testing deadline.
Right.
And your entire multi-million-dollar production schedule grinds to a halt.
Which the business will simply not tolerate.
Never. But as we see with Everest, if you leave that platform too open or govern it too loosely in the name of agility,
You end up handing your most valuable intellectual property directly to extortionists.
exactly. Just because a single account at a downstream supplier was compromised.
It is a brutal balancing act.
It really is.
And to truly understand why the standard defenses fail in the real world, we cannot just talk about this in the abstract.
No, we have to look at the mechanics.
Right. We need to look at the exact mechanical flow of an engineering file, tracing it from the moment it's created in a secure vault, right up to the moment it ends up on an extortionist's dark web blog. Now let's move into the technical breakdown.
So to visualize this, we really need to trace the entire life cycle of an engineering asset.
Right. We've analyzed the postmortem insights from the Mandiant blog, which extensively detailed Everest's operational mechanics.
Yeah, and we paired that with some incredibly vital technical research published in IE Explore.
Specifically regarding supply chain data leakage, right?
Exactly. When we synthesize this evidence, we can break this specific type of trust failure down into 6 highly distinct cascading stages.
Okay, so let's pull these apart stage by stage. Stage 1 is all about classification in the controlled repository.
Right, the starting point.
At the very genesis of a manufacturing project, the original equipment manufacturer, the OEM, the ultimate owner of the IP, creates the engineering asset.
They classify this data and they place it in a highly secure, centralized cloud repository.
And this environment is usually the crown jewel of their IT infrastructure, right?
Oh, absolutely. It boasts stringent identity and access management, incredibly robust file-level permissions,
Encryption at rest.
highly sensitive audit logging, all of it.
So the OEM generally feels extremely secure at this stage.
Yeah, they're looking at their dashboard, seeing all the green check marks, and just assuming the data is safe.
And this is exactly where the concept of data classification becomes so critical to the narrative here.
It really does. In their official press release following the breach, Stadler explicitly went on the record.
Right. They claimed that the stolen data was, quote, non-security relevant.
End quote. Yeah. The clear intent there was to reassure the public, their shareholders, and the national transit authorities.
Reassuring them that the core safety systems, the braking algorithms, or the critical train control software had not been compromised.
But I know you have some thoughts on that framing.
Yeah, I really have to stop and push back hard on that claim, honestly.
Go for it.
The phrase non-security relevant is highly subjective. And frankly, we have to look at it with a heavy dose of skepticism when it's coming from a victim actively trying to manage a PR crisis during an extortion event.
That's a fair point.
From a strict OT and engineering resilience perspective, that claim remains independently unverified.
Right.
Think about it mechanically. If an attacker gains access to the electrical schematics of a standard passenger car, maybe just the HVAC system or the lighting relays, that might sound harmless to a PR department.
But to an attacker,
Exactly. To an attacker, that information is an absolute goldmine for mapping out the broader network architecture of the train itself.
well, you are completely justified in your skepticism there.
Yeah.
From the vantage point of a sophisticated threat actor, there is almost no such thing as truly useless data when it comes to critical infrastructure.
None at all.
Even documents that appear mundane on the surface, like internal testing protocols, design documents for the physical seating arrangements, or even the specific software version numbers used in peripheral components. All of that can reveal a massive amount of operational intelligence.
It gives them your internal naming conventions. It maps out your supplier relationships.
Evers did not demand 10 million Swiss francs because they downloaded the cafeteria menus,
Right. They knew exactly what they had, and they knew it provided leverage.
But to maintain the timeline of our technical flow in stage 1, all of this data, regardless of its true sensitivity, is resting safely within the central, heavily fortified vault.
Right. But the train doesn't get built while the data just sits in a vault.
No, it doesn't.
Which leads us to stage 2, distribution to the prime contractor.
The OEM has to start provisioning access to specific external partners so the actual design and manufacturing work can begin.
And this is the moment we establish the first major trust boundary.
The OEM reaches out across the internet and grants access to a Tier 1 supplier, the prime contractor.
I always think the best way to visualize this mechanism for anyone outside of identity management is to picture giving an outside contractor a physical security badge to your corporate headquarters.
That's a great analogy, yeah.
But you don't give them a master key. You program that digital badge so it only opens very specific doors on very specific floors.
Exactly.
So you might give the prime contractor's engineering team access to the folder labeled brake system integration.
But you explicitly configure their permissions, so their badge absolutely will not work on the digital door labeled propulsion engine source code.
Right. You're explicitly limiting their blast radius in the event their badge is stolen.
Well, that is the architectural theory anyway.
Right.
And to be fair, in stage 2, it usually functions reasonably well. Prime contractors at the Tier 1 level are typically massive, highly mature organizations in their own right.
Sure. They have sophisticated security operations centers.
And crucially, they have mature identity providers, systems like Azure AD or Okta, that can directly federate with the OEM systems.
When you say strict federation in this context, just to make sure we're all on the same page, you mean establishing a digital trust pipeline, right?
Exactly.
Where the OEM's security brain is actively talking to the supplier's security brain to authorize the login.
Precisely. It means the OEM doesn't have to manage a separate username and password for the supplier's engineers.
Right.
When the prime contractor's engineer tries to log into the OEM's portal, the portal essentially says, "I don't know you. Let me ask your boss."
Right. It checks back with the prime contractor's identity system.
And because of this tight integration, the OEM can enforce their own strict security policies on that incoming connection.
So they can say, I don't care what your home policy is. To access this specific brake schematic, you must use a hardware-based multi-factor authentication token right now.
Exactly. And the detection opportunities at this stage are incredibly strong.
Yeah.
Your security team can correlate exactly who is logging in, what device they are holding, the specific project code they are assigned to,
The exact version of the file they're touching.
and whether their behavior matches the approved purpose of their task.
It's beautiful in theory, but the reality of manufacturing is that the prime contractor isn't building the entire train either.
No, they aren't.
And that harsh reality drops us into stage 3, delegation to lower-tier suppliers.
This is where things get messy.
The prime contractor realizes they need a highly specialized subcomponent manufactured, let's say a highly specific, custom-machined pressure valve for the pneumatic braking system.
So what do? They farm that task out to a Tier 3 or Tier 4 supplier.
And this is where the beautiful theoretical security architecture begins to face severe grinding friction.
Massive friction, because who are these Tier 3 and Tier 4 suppliers?
Right.
They are often incredibly small, hyper-specialized manufacturing shops.
They might employ the 5 best valve machinists on the planet, but their internal IT infrastructure is a decade old.
Exactly. They might be running legacy accounting software on Windows 7.
And their entire network might be managed by one person who also runs the HR department.
Yeah, their tools, their software licensing, and their internet connectivity are frequently entirely incompatible with the prime contractor's heavily controlled digital environment.
Let alone the OEM's original fortress.
Right.
You can see the collision course happening in real time here.
Oh, yeah.
The OEM mandates that everyone must use their specific, heavily monitored cloud collaboration tool.
But the Tier 4 supplier is using legacy 3D modeling software that physically cannot integrate with that cloud platform.
Or, just as commonly, the Tier 4 supplier doesn't have the budget to buy the expensive software licenses required to access the OEM's native environment.
Or perhaps their facility is in a location where the network bandwidth is simply too slow to constantly synchronize a 500 gigabyte CAD file back and forth from a central cloud repository every time they rotate the 3D model.
Right. The prescribed secure workflow starts to fundamentally break down.
And from a security telemetry standpoint, this is the exact moment where the OEM's visibility starts getting incredibly murky.
The SOC might start seeing strange anomalies in the logs.
Yeah, suddenly unknown organizations are popping up requesting access.
You see requests for generic shared guest identities rather than strictly federated individual accounts.
You see contractors demanding cross-domain data transfers.
Or asking for sweeping contractual security exceptions just to keep the project moving forward and avoid catastrophic delays.
And because the business demands that the project moves forward, we enter stage 4, export beyond the trust boundary.
This is the absolute danger zone.
It is. Because of all the friction we just talked about in stage 3, the engineers at those lower tier suppliers need a pragmatic way to actually get their jobs done.
Right.
So what is their only logical, immediate workaround?
They rip the file out of the cloud.
Exactly. They export the content, they take those heavily protected assets out of the controlled collaboration platform, and they download them as local files onto their own machines.
Saving them as raw CAD files, BIM building information, modeling models, or even just massive high-resolution PDFs.
And the crucial concept to understand here is what happens the millisecond that file is downloaded to a local C drive.
Right.
All of those beautiful, expensive, multi-million-dollar controls from stage 1, the encryption at rest, the strict access control list, the granular audit logging, they instantly vanish.
Wow.
The original protections simply do not travel with the extorted asset.
It is exactly like taking a priceless painting out of a museum.
That's a great way to look at it.
When the Mona Lisa is in the Louvre, it's behind bulletproof glass in a climate-controlled case, surrounded by laser tripwires and armed guards.
Right.
But the moment you take that painting out of the case and carry it out the front door in a plastic grocery bag, the painting itself hasn't changed.
It's still just as valuable.
But the protective environment is completely gone.
That is a perfect way to visualize it.
Ah.
The engineering data is now sitting on a local hard drive in an environment over which the OEM has absolutely zero technical control.
Now, I have to play the role of the manufacturing director here, though, and push back on the idea that security can just magically prevent stage 4 from ever happening.
Okay, let's hear it.
From an operational and engineering resilience standpoint, we have to deal with the unforgiving reality of production schedules.
Sure.
Let's put ourselves in the shoes of a mechanical engineer at that Tier 4 supplier.
Okay.
It's Friday afternoon. They have a hard contractual deadline to deliver a modified aerodynamic CAD file by 5:00 p.m.
Right.
The OEM's central portal is lagging because of a cloud outage, or their specialized rendering software strictly requires the file to be processed locally on the GPU of their high-performance workstation.
Yeah, very common.
How can a security team legitimately block that export function without completely halting the production of the train?
That's the million-dollar question.
You cannot just walk onto the manufacturing floor and tell the assembly line to stop welding because the security department said no offline copies allowed.
You are highlighting the exact paradox of supply chain security right there. You cannot paralyze the business.
Exactly.
If you block the export, the train doesn't get built and the company goes bankrupt.
Right.
But you have to view this from the attacker's perspective.
Okay.
This operational necessity, this exact moment of friction where security is bypassed for the sake of a deadline, is precisely the vulnerability that threat actors exploit. You are right that you might not be able to technologically prevent the export entirely without breaking the business.
Yeah.
But the critical failure is that you must govern the action.
What do you mean by that?
When that Tier 4 engineer exports the heavy CAD file, the security team inherently loses control of the file itself, but they absolutely should not lose the telemetry of the event.
Unpack that a bit. What does losing the telemetry actually look like in the SOC?
Well, it means that the action of exporting the data is, or at least should be, a highly monitorable event. When you look at the technical research from iExplore, they emphasize that this transition from stage 3 to stage 4 is where massive, blaring detection opportunities are completely missed.
Completely missed.
Yeah. When the data moves from the secure cloud to an unmanaged local drive, The OEM security systems should be screaming if the context looks even slightly abnormal.
Like what kind of context?
We are talking about monitoring for anomalous cloud synchronization patterns.
Okay.
If you have a single, newly created guest account that suddenly begins syncing 500 gigabytes of proprietary design files at 2 in the morning on a Sunday, that is a massive red flag.
That makes sense. Security teams should be alerting on bulk download thresholds.
Exactly. They should be tracking the loss of persistent protection labels.
Right.
For example, if a file is digitally tagged as highly confidential engineering eyes only, and the system detects, it is suddenly being converted into a standard, unencrypted, easily shareable PDF.
That conversion event itself must trigger an immediate high-priority alert.
Precisely. But looking at the mechanics of the Stadler case, those alerts either didn't trigger, they were buried in a mountain of false positives and ignored, or the visibility simply wasn't configured in the first place.
And that failure pushes us squarely into stage 5, peripheral exposure.
Right.
Once the data is exported and sitting on that Tier 4 supplier's local workstation, it becomes exposed to a completely different, highly hostile threat landscape.
Completely different.
We are no longer talking about advanced persistent threats trying to crack the OEM's firewall.
No. We are talking about the mundane reality of stolen credentials.
Completely unmanaged endpoint devices.
Employees dragging classified files into their personal consumer cloud storage so they can work from home over the weekend.
Or local repositories with no password protection whatsoever.
And this peripheral exposure is the lifeblood of groups like Everest.
We need to be very clear about how attribution works in this specific incident.
Yes, definitely.
The attribution to the Everest group is primarily based on the extortion letter itself and their known historical modus operandi of credential-based data theft.
Right. It is not necessarily based on deeply buried, sophisticated technical indicators or malware signatures found within Stadler's core network.
Why is that?
Because the actual breach happened out at the extreme periphery of the supply chain. Everest specializes in finding these exact weak links. They understand that they do not need to invest millions of dollars in zero-day exploits to break into the OEM's hardened digital fortress.
They just need to browse a dark web initial access market.
Buy a compromised credential for a Tier 3 supplier for the price of a cup of coffee.
Log into that supplier's poorly defended endpoint.
And quietly scoop up the exported CAD files that are sitting casually on a user's desktop.
And because the OEM lost sight of the painting the moment it left the museum, we hit the final fatal step. Stage 6, delayed detection.
This is the ultimate catastrophic failure point in the architecture.
Right. The operators, the OEM, Stadler in this scenario, retain perfect granular visibility right up to the exact millisecond the file is exported.
But they completely lack any telemetry, any logging, and any revocation capability out in those lower supply chain tiers.
The result is that by the time the OEM even realizes there is a problem, the data has already been gone for weeks, maybe months.
Yeah. They only discover the breach when an executive opens their email and finds a direct extortion demand from Everest.
Complete with a convenient zip file containing a sample of their own highly classified engineering diagrams as proof of life.
It's brutal. Mandiant's analysis of this threat actor behavior highlights this delay brilliantly.
Right.
The brutal truth is that any detection opportunity at stage 6 is entirely reliant on what we call compensating controls.
Meaning controls that don't prevent the theft but attempt to track it after the fact.
Exactly. We're talking about requiring digital receipt for downloads, maintaining complex copy traceability matrices,
enforcing time-based file expiry where a document theoretically self-destructs after a week.
Utilizing digital watermarking so that when the file shows up on the dark web, you can at least prove exactly which supplier leaked it.
And relying on airtight contractual requirements that legally force the supplier to notify you if they suffer an incident.
But let's be incredibly realistic about those compensating controls.
Yeah.
A digital watermark does absolutely nothing to stop the extortion demand once the data is already in Everest's hands.
It just helps you with the post-mortem autopsy to figure out who to sue.
Right. The reality is, if your security visibility fundamentally stops the moment an engineer clicks the export button, you are completely blind to the actual threat. Now let's turn to the operational decisions.
Because understanding the technical failure mechanisms, the 6 stages we just walked through, is really only half the battle.
The other, arguably more complex half, is how leadership teams translate those technical realities into actual business, operational, and regulatory decisions.
Right. The business impact in a scenario like this is profoundly severe.
We aren't just discussing a technical glitch or a temporary IT outage.
No, we are talking about a direct demand for 10 million Swiss francs.
And the reputational fallout is often vastly more expensive than the ransom itself.
Exactly. The Railway Gazette International covered the industry reaction to this extensively.
Yeah, they did.
When a major trusted infrastructure provider like Stadler suffers a breach of this magnitude and it becomes public, it sends absolute shockwaves through the entire global transportation sector.
Because their primary customers, the national railways, the federal transit authorities, the governments who buy these trains, they instantly start demanding aggressive, top-to-bottom security audits.
Right. And the general public reads the headlines and immediately begins questioning the physical safety of the trains they ride every day.
Regardless of how many press releases the OEM puts out claiming the stolen data wasn't security relevant.
Exactly. The operational consequences of losing control when digital assets cross those technological boundaries are profound and long-lasting.
Which brings us to the core disagreement and how the cybersecurity industry is currently attempting to solve this crisis.
Because right now, if you talk to CISOs across the manufacturing sector, there are two very distinct, often aggressively opposing philosophies clashing over exactly how to handle supplier access.
And I think we fall on different sides of this fence.
I think we do. I will gladly plant my flag firmly in the first camp.
Okay, let's hear it.
From a strict OT and engineering resilience perspective, I believe the only logically defensible way forward is strict federation, period.
Hey.
We simply cannot rely on shared passwords, generic guest accounts, or legacy authentication systems anymore. The stakes are too high.
I agree the stakes are high, but
We need to ruthlessly enforce phishing-resistant MFA multi-factor authentication for every single external partner, with zero exceptions granted for convenience.
zero exceptions. That's tough.
And beyond just how they log in, their access must be explicitly project-scoped and strictly time-limited.
Right.
This means embracing the concept of zero standing privileges. If a subcontractor is hired for a 6-month developmental sprint on a specific pneumatic braking component, their digital access should only allow them to see those specific folders.
Yeah.
Furthermore, the second that contract ends, their guest account must automatically self-destruct. No lingering access, no orphaned accounts sitting around waiting to be compromised.
I hear the conviction in your voice. I really do. But I have to ask, what specific frameworks are you basing that incredibly rigid stance on?
Well, I am looking directly at the ANISU guidance on supplier access management for critical infrastructure.
Right, the European Union Agency for Cybersecurity.
Exactly. And I'm also leaning heavily on the Sandus Institute white paper, specifically covering the topic of securing supplier-facing data repositories.
Okay, both solid sources.
Both of these authoritative documents are completely unequivocal on this issue. They argue forcefully that without explicitly defined trust boundaries and the enforcement of zero-standing privileges, credential theft and subsequent data extortion are not just possible. They are essentially statistically inevitable over a long enough timeline.
I see their point.
You simply cannot leave external accounts open indefinitely, and you absolutely cannot allow single-factor authentication when you are dealing with the blueprints for critical infrastructure.
Look, I understand the theoretical purity of that approach, but I have to challenge it from the perspective of an attacker, and more importantly, from the standpoint of business agility.
Okay.
If we leave the white papers behind and look at the gritty operational reality on the factory floor, enforcing that level of strict federation all the way down to a Tier 4 supplier is often functionally impossible.
Impossible.
Yes, the National Institute of Standards and Technology, specifically in NIST Special Publication 800-161, which covers supply chain risk management, and NIST's own subsequent Supply Chain Security 2023 report, both explicitly acknowledge the inescapable need for business continuity.
But surely business continuity shouldn't mean sacrificing your baseline security.
It shouldn't in theory, but it almost always does in practice when security policies become draconian.
How so?
Think about the friction we discussed earlier.
Right.
If you rigidly mandate phishing-resistant MFA, say, requiring physical FIDO2 hardware tokens for a 5-person machining shop that still runs their entire operation on legacy, potentially air-gapped systems,
You're going to break their workflow.
fundamentally break it. The hardware tokens might not even have a USB port they can plug into.
Right.
What I argue for is a much more pragmatic, flexible approach.
Which is?
We need to retain VPN-based access for these legacy partners, but combine it with rigorous, strictly enforced periodic credential rotation and heavy network segmentation.
Wait, let me stop you right there. Allowing a supplier to use a VPN just puts them straight onto your internal network?
No, not if it's segmented.
That is exactly how lateral movement happens. You are inviting the attacker to pivot directly from the supplier's compromised laptop right into your core routing infrastructure.
Not if the VPN is properly and aggressively segmented.
But it rarely is.
You don't give them a tunnel to your core network. You give them a tunnel to an isolated enclave that only houses the specific data they need.
Okay, but
Look, the harsh reality that strict Federation advocates often ignore is that overly rigid security restrictions do not actually stop engineers from sharing data.
they never have.
Exactly. They just drive the creation of shadow IT.
Right.
If that Tier 4 engineer is staring down a Friday deadline and they physically cannot get through your beautifully architected multi-factor authentication portal because their mandatory hardware token isn't compatible with their workstation,
They are not going to just sit on their hands, miss the deadline, and cost their company the contract.
not going to pick up their phone, call their buddy at the Tier 1 supplier and say, hey, I can't log into the secure portal. Just email me the CAD file to my personal Gmail account.
Or they'll quickly set up an unsanctioned Dropbox folder to transfer the files.
Exactly. And now your highly sensitive, supposedly locked down engineering data is completely ungoverned, entirely unmonitored, and sitting on a consumer-grade cloud server.
Wow.
By trying to be perfectly secure, you have actually created a massive, completely invisible vulnerability.
I hear you on the very real dangers of shadow IT, and I acknowledge that engineers will always find the path of least resistance.
Always.
But you cannot use the threat of shadow IT as an excuse to continue relying on vulnerable legacy VPNs.
It's not an excuse, it's a reality.
Furthermore, the way a lot of manufacturing organizations try to solve this exact tension is by hiding behind paperwork.
Oh, the paperwork shields.
Right. They point to international standards like ISO 2701.2022.
Right.
Specifically looking at the clause regarding supplier relationships.
Yeah.
The executives sit in a boardroom and say, look, we have a legally binding contract.
The supplier signed a comprehensive non-disclosure agreement.
Right. Promising they will maintain secure systems, apply patches, and they legally promised they won't make unauthorized copies of our data.
Yeah, that's how the meetings go.
But let's be brutally honest here. Contractual governance does not technically prevent a single byte of data from being copied or exposed.
No, it doesn't.
An Everest Group operator who just spent $5 on a compromised credential in a dark web forum does not care about the airtight non-disclosure agreement your supplier signed 3 years ago.
I will readily concede that point.
Thank you.
You are entirely correct that paper shields do not stop digital bullets.
Never.
Relying solely on a contract while ignoring the technical telemetry is a massive failure of technical governance.
Exactly.
And I will also partially concede your earlier point. Unmonitored, flat legacy VPN access is completely indefensible in today's threat landscape.
It really is.
But my core counterpoint remains valid.
Which is?
Enforcing strict, hardware-bound MFA on a Tier 4 supplier operating on antiquated systems might completely halt an engineering sprint.
Yeah.
If that specific sprint is on the critical path for delivering a multi-million-dollar train to a national government, the business leaders will force the security team to bypass the controls every single time to avoid the financial penalties of a delay.
So we find ourselves caught in a miserable catch-22.
Pretty much.
We are trapped between halting production by enforcing strict controls or inviting extortion by allowing flexible ones.
Right.
But there has to be a middle ground we can build on. What is the absolute non-negotiable baseline that both the strict Federation camp and the agility camp can agree on?
I think the ultimate convergence point for both of our philosophies, whether you advocate for strict zero trust federation or you argue for segmented flexible access, is the absolute uncompromising necessity for continuous monitoring and exhaustive audit logging of all supplier activity.
Right.
Regardless of the access method they use, whether they authenticate through a hardened cloud portal with a hardware key or they connect via a segmented VPN tunnel, you must have complete granular visibility into exactly what they are doing while connected.
So, if an authorized supplier account logs in from a known IP address in Zurich and downloads one specific CAD file they have been working on all week, that is normal operational behavior.
Exactly.
But if that exact same account logs in from an unknown IP address an hour later and attempts a recursive download of the entire project directory tree,
the security system must automatically flag that behavior, instantly isolate the account, and kill the session, regardless of the underlying authentication method that was used to get in the door.
I agree completely. When the preventative controls inevitably fail or are bypassed for the sake of the business, the audit log becomes the ultimate arbiter of truth.
It's the only thing you have left.
Right. If we cannot technically prevent every single export without destroying the workflow, we must at least know exactly when, where, and by whom the export was executed. This brings us to the pressure test.
Let's take all of this theory, all of these frameworks, and apply them directly into a real-world, incredibly high-stakes scenario.
Okay, let's do it.
I'm going to place you directly in the hot seat to see how you balance these competing priorities.
All right.
Imagine you are the Chief Information Security Officer of a major original equipment manufacturer.
Got it.
You are right in the middle of developing a revolutionary new high-speed train.
High stakes.
This project is highly publicized, heavily funded by government grants, and it is operating under incredibly tight, unforgiving regulatory and delivery deadlines.
Okay, the pressure is on. Put me in the room.
It is a Friday evening, much like today.
Of course he is.
Your Security Operations Center suddenly gets a massive Priority 1 alert.
What's the alert?
The telemetry indicates that a compromised supplier credential has just been used to access and successfully download a significant volume of design files related directly to the new high-speed train from your central collaboration platform.
All right, this is the nightmare scenario.
Yes, it is.
What do we actually know as of this exact minute?
That is the crux of the problem. The evidence you have is highly incomplete.
Which is how it always goes.
This is a rapidly developing situation. What we do know is that the compromised credential belongs to a Tier 2 supplier who is specifically responsible for the aerodynamic modeling of the train's nose cone.
Do we know the exact sensitivity of the files they actually downloaded?
We do not. The directory names they pull from are just generic alphanumeric project codes.
Okay.
They could have downloaded the highly classified proprietary aerodynamic cross-section models, or they could have simply downloaded the structural blueprints for the passenger luggage racks.
Right, we simply don't know the exact security relevance of the payload yet.
No, we don't.
What about the configuration of the platform itself? Did we have encryption at rest actively enabled on those specific directories before the download occurred?
Well, the platform definitely supports encryption at rest. But in the chaos of the moment, the SOC has not yet verified if it was actively enforced on this specific project's folders by the project managers.
Great. Furthermore, we probably do not have the complete timeline of the credential compromise itself.
Exactly. We don't know if the attacker just bought this password and logged in 10 minutes ago, or if they have had silent access to this environment for 10 months, slowly exfiltrating data.
Have we seen any technical evidence of lateral movement? Are they just taking files, or are they actively trying to pivot from the collaboration platform deeper into our core OT networks or our manufacturing control systems?
Currently, based on all available logs, there is zero public or internal evidence of lateral movement.
Okay, that's something.
And there is no indication whatsoever of a destructive ransomware payload being deployed.
Right.
This appears right now strictly to be a credential-enabled data exfiltration event.
Okay, so this is the binding constraint, the ultimate dilemma.
Yep.
As the CISO, we are staring down the barrel of a massive operational decision with potentially catastrophic consequences on both sides of the equation.
Pick your poison.
Option 1 is immediate revocation. I make the call right now to kill the supplier's access entirely, terminate all their active sessions, lock the service account, and essentially pull the plug on the network connection.
Which absolutely stops the data breach dead in its tracks.
Right.
But here is the business consequence of option 1. That specific Tier 2 supplier is on the critical path for next week's physical wind tunnel testing.
Ah, of course they are.
If you revoke their access right now, they cannot finish the modeling. You completely halt the train development schedule.
And a delay of even a few days on a project this size could trigger millions of dollars in contractual penalties.
And potentially derail the entire public launch of the train. The CEO is going to want a very good explanation for why you stopped the company over a potentially unverified alert.
Right. So that brings us to option 2. We maintain access.
Exactly.
We deliberately let the supplier keep working, even knowing there is a compromise, to keep the development schedule on track and avoid the penalties.
What?
But we rely on massively heightened surveillance. We watch that compromised accounts every single keystroke and network request like a hawk.
From a strict incident response perspective, if you choose option 2 and decide not to revoke access immediately, you have to implement temporary aggressive risk reduction measures instantly.
Right.
You cannot just sit back and watch them steal more data while you hope for the best.
No.
If we maintain access, we immediately force a global password reset on that specific supplier's account.
Okay.
We transition them immediately to short-lived guest accounts for their engineers, meaning their access tokens literally expire every few hours and force them to re-authenticate from scratch.
And we absolutely must force phishing-resistant MFA on all their logins starting right this second.
Regardless of whatever friction it causes their legacy system.
Exactly. If they want to keep working this weekend to hit the wind tunnel deadline, they use an authenticator app or a hardware key, no exceptions.
Furthermore, we have to utilize incredibly strict project scope permissions that auto-expire.
Right.
We go into the system and restrict their access so tightly that they can only see the specific aerodynamic files they absolutely need for the wind tunnel test.
And not a single kilobyte of data outside of that folder.
And finally, we turn the SOC's audit logging up to the highest possible sensitivity, capturing every single interaction.
I have to push back on the residual risk of option 2, though.
Let's hear it.
Even if we deploy short-lived tokens and force MFA, what if the underlying identity governance at that Tier 2 supplier is fundamentally rotten?
What do you mean?
What if the attacker hasn't just compromised one single engineer's credential, but has actually compromised their entire underlying Active Directory infrastructure?
Oh, I see.
Forcing an MFA prompt on a compromised user does absolutely nothing if the attacker already has remote control of the physical device that is receiving the MFA prompt.
That is a very fair point.
Maintaining access under these conditions feels like deliberately leaving the vault door cracked open simply because we are terrified of missing a project deadline.
It is a massive, uncomfortable risk. I won't deny that.
Yeah.
But unilaterally halting a multi-billion-dollar engineering project based on an unverified volume of downloaded data is also a massive career-ending risk for a security leader.
That's true, too.
We have to find a way to balance the theoretical security purity with the unforgiving demand for operational continuity.
Okay, we need to form a defensible decision right now. We cannot just let the data burn while we debate, and we cannot blindly shut down the factory without absolute proof.
Oh, it's a call.
Let's combine the approaches into a unified strategy. We will maintain the access for this specific Tier 2 supplier so they can keep the wind tunnel testing on schedule.
Okay.
But we will only do so under the intensified monitoring and the temporary controls you outlined.
Forced MFA, severe project scoping, and short-lived tokens.
Exactly.
But that cannot just be a polite, open-ended agreement. We must establish a strict, absolute zero-tolerance escalation trigger with the SOC.
Agreed. The escalation trigger is defined exactly like this. If our SOC detects any use of additional compromised credentials originating from that supplier's domain,
or if we see any anomalous data exfiltration volumes, meaning they try to download anything outside of the specifically approved aerodynamic models required for this weekend's test,
their access is instantly automatically severed without waiting for executive approval.
And I would add one more critical condition to that escalation trigger.
What's that?
If there is any hint, any anomalous network ping, or any unauthorized access attempt directed toward our core production systems, our safety systems, or our OT networks that originates from their assigned IP ranges.
The connection is burned immediately.
Exactly. No questions asked, no schedule considerations entertained.
That is a highly defensible decision. We preserve the business continuity under extreme duress, but we establish a technical tripwire.
Right.
A tripwire that shifts us automatically from passive monitoring to total, ruthless revocation, the absolute millisecond the attacker deviates from the constrained environment.
It requires a highly mature security operations center to actually execute that flawlessly.
It really does.
But it is truly the only viable way to navigate the binding constraint of supply chain dependencies during an active unfolding incident. Finally, let's close with the key takeaways.
If we step back and synthesize everything we've unpacked today, Without introducing any new frameworks or outside evidence, the broader picture becomes crystal clear.
It does.
The Stadler case fundamentally reframes exactly how we need to view threats directed at the manufacturing sector.
Because the true underlying threat highlighted here is that credential-based data theft across vulnerable supplier boundaries is the immediate, most pressing danger.
Right.
The entire industry spends millions preparing for the catastrophic, destructive OT ransomware attack that physically shuts down the assembly line.
But this specific case proves that silent data exfiltration leading directly to a massive extortion demand is arguably much more common.
Much harder to detect and equally devastating to the business's bottom line.
Because the attackers have evolved. They have realized they simply don't need to figure out how to break your complex proprietary OT machinery. They just need to steal the engineering blueprints for it from your weakest, least offended partner and demand 10 million Swiss francs to keep it quiet.
Right. And the path forward for the industry is clear, even if it is difficult to implement.
Very difficult.
Securing and governing supplier access platforms is no longer just an IT problem, it is a core business survival strategy.
Right. It requires explicit, verified trust.
You must enforce federated identity wherever possible, and you must deploy tightly scoped, heavily monitored controls.
As we discussed throughout the deep dive, this is the only sustainable way to protect critical engineering data while simultaneously preserving the vital, rapid supply chain collaboration that allows complex products to actually be built.
It all ultimately comes down to continuous visibility and rigorous control.
We simply cannot accept non-security relevant claims at face value, and we absolutely cannot allow our security perimeter to magically evaporate the moment an engineer clicks export.
Which leaves us with a final challenge for everyone listening right now.
Let's hear it.
We want you to critically evaluate your own operational environment. Look closely at your own supply chain.
Where exactly does your visibility stop?
At which specific tier of your supply chain does your telemetry go completely dark, leaving your most sensitive engineering data entirely exposed on an unmanaged, poorly defended desktop?
Ultimately, what we've unpacked today with the Stadler Rail extortion is a fundamental trust failure at the supplier boundary.
It's a complex issue, but one we must confront head-on. Thank you for spending part of your Friday with us. Have a safe and secure weekend, and we will be back next week with a new deep dive. Thank you for listening to Cybersecurity Under Pressure. Real attacks, real lessons.
You have been listening to Cybersecurity Under Pressure. Real attacks, real lessons. Real incidents leave real lessons. Stay prepared. Stay critical. And keep following the evidence.